So we're talking today about attributes of quadratics. So it's important to remember that a quadratic is going to be a parabola. Looks roughly like this U up here. The equation always has an x squared in it. And the graph, again, just as a reminder, is called a parabola. So the parabola can look one of two ways. It can open up, like this one down here at the bottom, or it can open it down, like this one here at the top. And the direction that the parabola opens depends on whether or not the graph is a positive x squared or if the graph is a negative x squared. So we're going to label all of these pieces that you see over here to the left. We're going to label all of these on the graph, and a lot of them you're going to already know. We're just reviewing what they are. Some of them are new, a couple of them are new. So let's start with the vertex, just go in order here. And I'm going to color code this. So my vertex is always either the highest point on the graph or it is the lowest point on the graph. It depends on which way the graph is opening. The vertex is also known as either your maximum or your minimum. Maximum is going to be at the top of the graph. So when the graph opens down, this point is called a maximum. And the minimum is going to be at the bottom of the graph. So when the graph opens up, it has a minimum value. The next word we see is an x-intercept. So x-intercepts, those are going to be points on the x-axis. A parabola can have at most two of those. We'll talk about why next week. So the x-intercepts are going to be on the x-axis. It's important to remember that x-intercepts are always written as x and then 0. These points have several names. One other name for them is they're also known as the solutions, or they are known as the zero of the function. So those three words, x-intercept, zero of the function, and solutions, all are referring to the points on the x-axis. Now, I am not physically labeling these, so you may either need to color code or you may need to actually write that this point is the x-intercept, the zero of the function, and the solution. Our next word is y-intercept. Well, y-intercept is going to be the point on the y-axis. And it's important to remember that y-intercepts are always written as 0 and then some number. Next we have positive x squared, and then after that negative x squared. So positive x squared is going to happen when the graph opens up. So I'm going to label this graph as a positive x squared. And then when the graph opens down, that's because the graph has a negative, or the equation has a negative x squared in it. And I'm going to put a check mark beside both of those. Okay, the next thing we have is our axis of symmetry. So the axis of symmetry is a line that goes through the middle of the graph that splits it in half. And more importantly, the axis of symmetry always goes through the vertex. So the axis of symmetry is the line that splits the graph in half, and it goes through the vertex. I'm going to write that part on there, that it goes through the vertex, because that's going to be critical later. Through the vertex. All right, our last couple words that we have here, increasing interval and decreasing interval, are brand new words. So if you think about the word increasing, increasing means to go up, and decreasing means that we are going down, so we're getting smaller. It is important to remember, before we discuss what increasing and decreasing is, remember that we read graphs from left to right. It's important to remember that we read graphs from left to right. So if you think about, let's start with the negative x squared graph. As you read this graph from left to right, if you start at the left side and you follow the graph, currently you are going up, so this interval right here is increasing because when you go from left to right, you're moving up on the graph. And then once you pass the axis of symmetry of the vertex, your graph starts to go back down, so this would be a decreasing interval. So on the left side here, we have an increasing interval because it is going up. And then on the right side, we have a decreasing interval because the graph is going down as we read it from left to right. And we're going to look at numbers in a minute to decide how we determine what interval that is specifically. Right now, we just need to understand what it means to be increasing and decreasing. So as we look at our positive x squared, if we begin on the left side, well, at first, when I'm reading from left to right, I'm going down. So it's a decreasing interval to begin with because the graph is going down. And then if I continue to follow the graph along past the vertex, it begins to move up. So then my interval becomes an increasing interval. Because the graph is moving up as I read it from left to right. So that's all of our words that we need. I'm going to zoom out. So if you want to take a picture of this and you can see everything you can, since mine is color coded, or again, you can color code your own if you need to do that. We're going to talk about the quadratic parent function for a minute, and then we're actually going to get into some other quadratics and identify all these pieces that we just talked about. So the quadratic parent function is the equation y equals x squared. It's the most basic graph you can come up with. This particular graph goes through the points -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And the way I got those was if I took my x value and then I squared it, because it said here that y equals x squared. If I plugged -3 in here and I squared it, I got 9. If I squared -2, I get 4. So that's where these numbers on the right side came from. So my graph is going to go through those points, which I'm going to go ahead and plot now. So I have points at 0, 0. I have points at -1, 1 and +1, 1. I have points at -2, 4 and +2, 4, and -3, 9 and +3, 9. So this would be my quadratic parent function. This is the graph y equals x squared. We're going to talk about that for a minute and just identify some other features about it. So the quadratic parent function opens up, obviously. The y-intercept is going to be 0, 0 because that is where the graph crosses the y-axis. The vertex in this particular problem is also 0, 0 because that is the bottom of the graph. The axis of symmetry is x equals 0 because the y-axis, or the equation x equals 0, is what splits the graph in half. The quadratic parent function has one real solution. That solution is the x-intercept, has one real solution, which is at 0. The domain and range are the next things we need to talk about. So the domain is going to be -infinity is less than x, which is less than infinity. Remember, when I'm trying to find my domain and range, I'm looking for the left side of the graph and the right side of the graph. Well, if you think about your parabola, my left side over here is an arrow, which means it just keeps going. My right side is also an arrow, so it keeps going. Because recall that domain we read from left to right. Range, we're going to read from bottom to top. So we're looking for the bottom of the graph and the top of the graph. Well, the bottom of our graph is going to be down here at 0. And the top of my graph, so 0 is less than or equal to y. The top of my graph, well, from what we can see, the top has arrows at it. So that means this graph is going to keep going forever and ever and ever towards positive infinity. So 0 is less than y, which is less than infinity. So this is going to be my domain and range. It is important to note that my domain for all quadratics is the same. This is true for all quadratics. My domain is always negative infinity to positive infinity for quadratics. My range is going to have to do with the vertex. The range always has to do with the vertex. We're going to talk a little bit more about that in a second. All right, so we're going to look at graph number 1 over here to the right, and we're going to identify all of these pieces: the vertex, axis of symmetry, domain, range, y-intercept, x-intercept, max or min, increasing interval, decreasing interval, standard form, and zeros. So let's go ahead and fill in the domain, because we just said a second ago that domain was always the same for quadratics, and it is negative infinity is less than x, which is less than infinity. That is never going to change. And then let's go to our vertex. So my vertex is, you could call it the elbow of the graph. It's where the graph bends. It's either the maximum or the minimum. So we just have to figure out which one that is in a second. So my vertex in this case would be this point right here, which is the ordered pair. It's a little hard to see where, just the way this graph is drawn, it's not labeled very well. So I'm going to highlight the x-axis. This is the x-axis, and highlight the y-axis. And this is my y-axis. So here's my origin, 0, 0. So this point, my vertex in this case, is the ordered pair, -1, +1. And since this is at the bottom, then my graph has a minimum, and the minimum value is going to be 1, because think about the word minimum. Minimum means lowest, so the lowest point on the graph is down here at -1. It's important to note, and you may want to make a note of this, that your minimum or maximum is always a y value. It is always a y value. It's always a y value. We're also going to go ahead and identify our range, because our range has to do with this maximum or minimum. So if we read our range from bottom to top, that's what we said a second ago, was that my range goes from bottom to top. Well, the bottom of my graph is at 1. So my range is going to go from 1 is less than or equal to y, which is less than infinity, because it's going to go on forever and ever and ever. So the top of my graph is at positive infinity, because this graph never stops going up. We can identify our y-intercept next, and it really doesn't matter what order you identify these in. We're just kind of doing it in an order that seems to make a little bit of sense and connecting things together that makes sense. So my y-intercept is a point on the y-axis, which would be here. That is at the value 2. So my y-intercept as an ordered pair is going to be the ordered pair 0, 2. I have a couple things left, so let's go to x-intercept and zeros. It's important to remember these two are the same. These are the same. X-intercepts and zeros mean the same thing. It's where the graph crosses the x-axis. Well, if this is my x-axis and this is my graph, it doesn't ever cross the x-axis, so there are no x-intercepts. I'm going to put none here. Don't put 0 there, because 0 is not the answer. None is the answer. There is not one. All right, axis of symmetry, that is going to be the line that goes through the vertex that splits the graph in half. That's the line I'm currently drawing in pink. Axis of symmetry is always x equals, and the reason it's x equals is because it's a vertical line. It's an undefined slope, so its equation is x equals, and it's wherever it crosses the x-axis. In this case, that would be -1. The last thing we're going to talk about is this increasing and decreasing interval. So when we talk about our increasing interval, remember, increasing is where the graph is going up. Our decreasing interval is where the graph is going down. So if we follow the graph from left to right, when we begin on the left side, the graph is first going down, so that means that it is decreasing at this moment. So currently my graph is decreasing. And what we say is, when we read our increasing and decreasing intervals, they have to do with x. Increasing and decreasing has to do with x. So if we think about this from the left side, it's kind of like domain. It's almost like we're splitting our domain into two parts. So the left side of my graph is at -infinity, is less than x. And then when we get to the vertex, which is here at -1, that is when my graph stops decreasing. So we'll say that it decreases from negative infinity is less than x, which is less than -1. It is decreasing on that interval. And then when we look at increasing, well, if we keep following the graph around, increasing is when the graph starts moving up. Well, if I pass the vertex, I pass the axis of symmetry, my graph begins to move up. So it's going up on the right side, that made it increasing. Down on the left side, that made it decreasing. So we would say that our graph is increasing from, well, it started increasing here at -1, and it increased all the way to positive infinity. So I basically took my graph and I split it into two parts. So your increasing and decreasing intervals, they're always going to have to do with x every single time. The last thing it asked you to find was standard form. We are actually not going to be finding that for any of these problems, so it will be something that we will address later next week. All right, let's look at graphs 2 and 3. So we're going to begin by finding our vertex. Our vertex, remember, is either the bottom or the top of our graph. So it'd be down here. This ordered pair looks like -0.5. And I'm going to guess that that other value is -12.5. So it's the ordered pair -0.5, -12.5. Which that also gives us our maximum or minimum. In this case, it gives us a minimum. And that minimum would be that bottom value of the graph, which would be -12.5. And that also gives us our range. It means that -12.5 is less than y, which is less than infinity, because the bottom of the graph is at -12.5. The top of the graph is going on forever and ever and ever. Let's find our y-intercept next. The y-intercept is where the graph crosses the y-axis, which that's easy. That looks like it's at -12, so that's the ordered pair 0, -12. My x-intercepts are where the graph crosses the x-axis, and there are two of those in this case. One of them is at -4, so -4, 0, and the other one is at 3, 0. And that's going to be the same for my zeros, -4, 0, and 3, 0, because zeros and x-intercepts are the same thing. My domain, we said a second ago, was always negative infinity is less than x, which is less than infinity, because this graph just goes on forever and ever and ever. And then my axis of symmetry is the line that splits the graph in half. It always goes through the vertex. So it's going to be x equals -0.5. And this -0.5 value that we have here is the same as this -0.5 that existed in the vertex. Those two are always the same. All right, our last is our increasing and decreasing intervals, which is going to be, again, the most difficult part of this. So let's read the graph from left to right. So if we follow the graph from left to right, we begin by decreasing. So this left side here is going to be my decreasing interval. This left side is going to be my decreasing interval because the left side is going down. And that starts at negative infinity, which is less than x. And it stops at the vertex. It's going to stop at -0.5. And notice again that this -0.5 value here is the same as what happened, or what we saw in our axis of symmetry and in our vertex. So here, this -0.5 here showed up in all those places. And then if I continue following the graph after the vertex, well, the graph begins to increase. That means it's going up. So it is increasing on the right half, which is the interval -0.5 is less than x, which is less than negative infinity. Now notice on both of these, when I talked about my increasing and decreasing, neither time did I use a less than or equal to symbol. I just used less than. And the reason is because at negative 0.5, it's not doing either. It's not increasing or decreasing. So we can't put equal to because it's not doing that at either one of those places to be exact. Again, we don't have to worry about finding this standard form, so you can mark that out, and you will be able to mark that out on your homework as well. All right, our last problem, graph number 3. Let's begin with the vertex. That's the first one up there. So the vertex, either the top or the bottom of the graph, which is here. That's at the top. It looks like it's at negative 3.5, and I'm going to guess that's probably 2.25. It's not quite in the middle there, so I'm going to say it's at 2.25. I'm going to go in order this time. My axis of symmetry is the line that's going to go through the middle of the graph. That splits the graph in half. And that is always x equals some number. And remember, that number comes from the vertex, so negative 3.5, because it crossed the x-axis at negative 3.5. Then my domain, we said, was always negative infinity is less than x, which is less than infinity. If you're tired of writing that because you don't like writing infinity symbols, you can always write our symbol for all real numbers, which means the same thing. We talked about that last week. It's that double R. Make it look a little bit better, but you're welcome to write that as your domain as well. That is perfectly fine. My range is going to be from the bottom or the top of my graph. Remember, I read range from bottom to top. So if I look at the bottom of my graph, well, the graph is just going down forever. So that means it starts at negative infinity is less than y. And the top of my graph is up here. That y value we decided was 2.25. So that means that it is less than 2.25. My y-intercept is where the graph crosses the y-axis, which we can see that happening here at negative 10. So it's the ordered pair 0, negative 10. X-intercept is where the graph crosses the x-axis. This happens twice at negative 5, 0, and negative 3, 0. And then my maximum or minimum has to do with my vertex. Well, since the graph has a top point, it has a maximum. And the maximum is whatever that highest value is, which in this case was the 2.25. Remember that your vertex, your max or min, and your range all have to do with the same number. And then the other part of that is that your vertex has to do with your axis of symmetry, and it's going to have something to do with our increasing and decreasing intervals, which we're going to get to now. So then I look to find increasing and decreasing. My increasing is where the graph is going up, and then decreasing is where the graph is going down. We start on the left side, and we follow the graph along. As I follow it, I'm currently increasing. I'm going up until I get to the axis of symmetry. So my graph is increasing. It's going up on the left side, which would be from negative infinity is less than x, which is less than, and it stops increasing at negative 3.5. Again, that number, I didn't make that number up, that number comes from the vertex, from the axis of symmetry. They're the same number every time. So then I look at decreasing interval. Well, if I keep following my graph around, after I pass the axis of symmetry, my graph begins to decrease. It starts to go down. So the right side is the decrease side, because the right side is going down towards negative infinity. So my interval for decreasing would be from negative 3.5, because that's where that started at, right here at negative 3.5, all the way to positive infinity. So it's less than x, which is less than infinity. Remember that, and this is where things get confusing. You just have to think about this. If you think about the fact the graph is going towards negative infinity, that's going to confuse you. That's not what we're talking about with the increasing and, well, that is what we're talking about, but that's not what we write with increasing and decreasing intervals. What we write is we're writing the x values when the graph is going up and the x values when the graph is going down. So this has to do with our x's, not what we write has to do with our x's, not our y's. We said a second ago we're not talking about standard form. So I'm going to go ahead and mark that out. And remember, my zeros are the same as my x-intercept, so my zeros would also be -5, 0, and -3, 0.